Hello everyone, today, we're diving into the TOLC exam, a crucial step particularly for students aspiring to enter fields like economics, law, and business administration. Whether you're prepping for university entrance exams or just love to challenge your math skills, you're in the right place. Let's get started. Now, let's talk about the mathematics section. This is where many students feel the heat, but don't worry, we've got you covered. We've solved 13 different math problems that could be similar to what you might encounter in the TOLC exam.
These problems cover a range of topics, including circular permutations, simplifying expressions, polynomial division, slope of perpendicular lines, median calculation, undefined functions, logarithmic equations, ratio and proportion, factoring polynomials, algebraic fractions, systems of equations, exponential equations, simplifying complex expressions. If you're looking to get some practice or just curious about the types of questions you might face in the TOLC exam, head over to www.prep-test.com. They offer free practice tests and a variety of questions to help you prepare. It's a fantastic resource, and I highly recommend checking it out.
The problem states that we have two numbers which add up to 50 and have a ratio of 3 to 2. To solve problems involving ratios, we use the concept of parts. In this case, the ratio is 3.2, meaning the first number is 3 parts and the second number is 2 parts. Let's call the first number 3x and the second number 2x, where x is the value of each part. Their sum is 50, so the equation is 3x plus 2x equals 50. To find the value of each part, we solve for x. 5x equals 50, so x equals 10. Now, the first number, 3 parts, is 3x, which is 30. The second number, 2 parts, is 2x, which is 20. The question asks for the difference between the larger and smaller number. Subtracting the smaller number from the larger, 30 minus 20, gives us 10. Therefore, the difference between the larger and smaller number is 10. This question involves the concept of circular permutations. When arranging people around a circular table, one seat is usually fixed to avoid counting rotations of the same arrangement as different. For linear arrangements, we would simply use the factorial of the number of people, which in the case of 5 people would be 5 factorial. However, because it's a circular arrangement, we consider one person's seat as fixed and arrange the remaining people around them. So for 5 people, we fix one person's seat and arrange the remaining 4 people around the table. The number of ways to arrange 4 people is 4 factorial. Let's compute 4 factorial. 4 factorial equals 4 times 3 times 2 times 1. 4 factorial equals 24. Therefore, there are 24 different possible seating arrangements for a group of 5 people around a circular table where the arrangement is considered different only when the positions of the people are different relative to each other. To solve the problem shown, we need to simplify the expression given. The fourth root of 64 over 81, raised to the power of 1/4. Let's break it down step by step. First, we need to recognize that the fourth root of 64 is asking for the number that when raised to the power of 4 equals 64. We know that 2 to the power of 4 equals 16 and 4 to the power of 4 equals 256, so the fourth root of 64 is between 2 and 4. Since 2 times 2 equals 4 and 4 times 4 equals 16, it follows that 2 times 2 times 2 equals 8, and 8 times 2 equals 16. So 2 times 2 times 2 times 2 equals 16. Hence, the fourth root of 64 is 2 to the power of 3, which is 8. Therefore, the expression simplifies to the fourth root of 81 over 8, raised to the power of 1/4. We are given a polynomial p of x equals x cubed minus 2x squared plus k minus 3, which is divided by the polynomial a of x equals 2x minus 1, and the remainder is r equals -2. When a polynomial p of x is divided by a binomial of the form ax minus b, the remainder can be found by substituting the root of the binomial into the polynomial. The root of the binomial a of x equals 2x minus 1 is the value of x that makes a of x equals 0, which is x equals 1/2. To find k, we substitute x equals 1/2 into p of x and set it equal to the remainder -2. P of 1/2 equals 1/2 cubed minus 2 times 1/2 squared plus k minus 3 equals -2. Now, let's solve for k using this equation. After solving, we find that the value of k that satisfies the given conditions is 11/8 or 1.375 in decimal form. So, the correct answer from the given options is k equals 11/8. To find the slope of a line that is perpendicular to another line, we use the negative reciprocal of the slope of the original line. The given equation of the first line is 4x minus 2y equals 5. This is in the standard form x plus by equals c. To find the slope, m, we need to rewrite it in slope-intercept form, y equals mx plus b, where m represents the slope. Rearranging the given equation to solve for y, we get -2y equals -4x plus 5, which simplifies to y equals 2x minus 5 over 2. The slope of this line is the coefficient of x, which is 2. Now, the slope of a line perpendicular to this one would be the negative reciprocal of 2, which is -1/2. Therefore, the slope of the line that is perpendicular to the given line is -1/2. The task is to find the median amount earned per day over a 20-day period where the amount earned each day varies. The table in the question provides the amounts earned and the number of days each amount was earned. First, let's list out all the earnings for each day in ascending order to find the median. The median is the middle number in a sorted, ascending, or descending list of numbers and can be more descriptive of that data set than the average. The table shows that the student earned $96 for 4 days, $84 for 7 days, $80 for 4 days, $70 for 3 days, $48 for 2 days. To find the median, we need to organize these earnings from the smallest to the largest, and then find the middle value. Since there are 20 days in total, the median will be the average of the 10th and 11th day's earnings when listed in order. Let's organize the data and find the median value. The median amount earned per day over the 20-day period is $84. This is the middle value of the organized earnings, meaning that for half of the 20 days, the student earned less than or equal to $84, and for the other half, they earned more than or equal to $84. To determine for which positive values of x, the function f of x equals 1 over x squared minus 5x minus 14 is undefined, we need to find the values of x that make the denominator equal to 0, because division by 0 is undefined in mathematics. The denominator is a quadratic expression that can be factored to find its roots. The expression is x squared minus 5x minus 14. To factor this quadratic, we look for two numbers that multiply to 14 and add up to 5. These numbers are 7 and plus 2. So the factored form of the denominator is x minus 7 times x plus 2. Setting each factor equal to 0 gives us the values of x that make the denominator, and thus the function, undefined. X minus 7 equals 0, or x plus 2 equals 0. Solving these equations gives us the values of x. X equals 7, or x equals -2. The equation provided is log base a of a cubed plus a squared minus 8 equals 2. The logarithmic property states that if log base b of m equals n, then b to the power of n equals m. We can apply this property to solve for a in the equation given. A squared equals a cubed plus a squared minus 8. Now let's solve for a by simplifying the equation. 0 equals a cubed minus 8. 0 equals a cubed minus 2 cubed. This is a difference of cubes, and it factors as 0 equals a minus 2 times a squared plus 2a plus 4. From the factored form, we can see that a equals 2 makes the first factor 0. To solve the logarithmic equation log of 3x plus 1 equals 5, we can use the definition of a logarithm. The equation log base b of m equals n is equivalent to b to the power of n equals m. In this case, the base b is 10 because no base is specified, which by convention means it's a common logarithm, base 10. Thus, the given equation can be rewritten as 10 to the power of 5 equals 3x plus 1. Let's solve for x. 10 to the power of 5 equals 1,000,000. 1,000,000 equals 3x plus 1. 3x equals 1,000,000 minus 1. 3x equals 99999. X equals 9999 divided by 3. Now we calculate the value of x. The value of x that solves the equation log of 3x plus 1 equals 5 is x equals 33,333. The expression is x to the power of 4 plus y to the power of 4 over xy to the power of 3. First, we separate the terms in the numerator and then divide each by the denominator. X to the power of 4 plus y to the power of 4 over xy to the power of 3 equals x to the power of 4 over xy to the power of 3 plus y to the power of 4 over xy to the power of 3. Now, let's simplify each term separately. For the first term, x to the power of 4 over xy to the power of 3 equals x to the power of 4 over x to the power of 3y to the power of 3. When you divide powers with the same base, you subtract the exponents. So we get x to the power of 4 over x to the power of 3. Y to the power of 3 equals x over y to the power of 3. For the second term, y to the power of 4 over xy to the power of 3 equals y to the power of 4 over x to the power of 3y to the power of 3. Again, applying the laws of exponents, we get y to the power of 4 over x to the power of 3y to the power of 3 equals y over x to the power of 3. Putting it all together, the corrected simplified form of the original expression is x over y to the power of 3 plus y over x to the power of 3. The problem states 80% of participants in a coding contest completed their tasks successfully. Of those who completed their tasks, 25% scored above 90%. We are asked to find what percentage of all participants scored above 90%. To solve this, we multiply the two percentages together because we want to find the subset of the subset. The percentage of all participants who scored above 90% equals 80% times 25%. To multiply percentages, we convert them to their decimal forms and then multiply. 80% equals 0.80 and 25% equals 0.25. So 0.80 times 0.25 equals 0.20. Converting the decimal back to a percentage, 0.20 equals 20%. Therefore, 20% of all participants scored above 90%. To find out which of the given binomials, the polynomial x squared plus 4 times x cubed minus 7x squared plus 12x is divisible by, we can use the remainder theorem. According to the remainder theorem, if a polynomial fx is divided by a binomial of the form x minus r, the remainder of the division is fr. We'll evaluate the polynomial for each root candidate given by the binomials. For x plus 2, use x equals negative 2. For x minus 2, use x equals 2. For x minus 7, use x equals 7. For x minus 3, use x equals 3. For x plus 4, use x equals negative 4. The polynomial is divisible by the binomial if the result of the substitution is 0. Let's perform these substitutions and check the results. The polynomial x squared plus 4 times x cubed minus 7x squared plus 12x is divisible by the binomial x minus 3, since the substitution x equals 3 yields a result of 0, which means the remainder is 0, and thus the polynomial is divisible by x minus 3.